Hi, and welcome to 9 IST Data Handling, Lesson 5, Data Storage and Function. Here are the syllabus dot points. Pause if you'd like to read them. So when we have storage, we can divide it into two types of storage. We have primary and secondary storage. Primary storage is the most important and most used storage to a computer. It can store the data that the CPU needs instantly accessible. While most people will consider a hard drive primary storage, in reality, it's RAM, ROM, and various caches. It's really important to note that point. Primary storage is not a hard drive. It's not the biggest part of storage. In fact, it's often the smallest type of storage on a computer, but it is the most important to the processor. Secondary storage is everything else. So that incorporates hard drives, disk drives, CDs, DVDs, USB, etc. So what is RAM? RAM is random access memory, and it's temporary memory that can be written to and read quickly. It is used to store data temporarily for use by the processor when it's working on a task. Example, a program might be loaded into RAM when you open it. Because of its temporary nature, it is cleared every time the computer is turned off, and that also gives its other name, volatile memory. So when you store something in RAM, it's wiped every single time you turn the computer off. So it's good for temporary stuff, but you can't store anything important in RAM. So this is why, for instance, if you're working on Word and you haven't saved your document, you turn your computer off, it's gone, you can't access it again. The document was stored in RAM instead of on the hard drive. ROM stands for read-only memory, and it stores data that is important to the computer but shouldn't be changed regularly, called firmware. In a computer, data in ROM can include things such as the BIOS, which stands for Basic Input-Output System, and it's the software that runs underneath the operating system and launches the operating system when your computer boots. Your mobile phone has firmware, which is stored in ROM, and most devices nowadays would have some sort of ROM to help it function. Okay, it's for information that's not meant to change, as I said, read-only memory. Cache is similar to RAM in that it's temporary and fast, stores data for the processor, but only about calculations it is doing currently. So very similar to RAM. It's hard drive, RAM, cache, processor, and that's how data is generally moved. And then it goes back, processor, cache, RAM, hard drive. Secondary storage devices, as stated earlier, are everything that isn't RAM, ROM, or cache. So secondary storage devices can take many forms, including things such as magnetic tape, magnetic disks, optical disks, which are CDs, DVDs, Blu-rays, etc., and flash memory such as USBs and SD cards. There are two types of access methods. We've got sequential access, where data is read and written in the order that it is written on the device. For example, a tape. When you are listening to or watching a videotape, you need to fast forward to the point where you want to access it before you can begin watching or listening. And the best example of this is magnetic tape. IT firms and companies often use magnetic tape, just like a videotape, to back up their data, as it's a very stable form of data for storage. So just like you wouldn't have a normal tape, you start at the start, you press play, and you start recording. Exactly the same way. We also have random access, where data can be read and written in any order you like, and that's basically every other device. CDs, random access, hard drives, random access, etc. When we store, we also have bits and bytes. So a bit is the smallest piece of data on a computer, and it's either a 1 or a 0. And for convenience, these are assembled together into bytes. 8 bits is 1 byte. And all storage on computers is measured in bytes. Data transfer is generally measured in bits per second, not bytes per second, due to the generally smaller nature of data we're transferring. For larger versions of these, we use the SI, or the System International d'Unit, system of prefixes. Okay, so it's the standard system across the world, written in French, because French is an international language. So this is the table that we have of the various prefixes. We can see here the prefix name, the prefix symbol, the power of 1,000, the power of 10, and the actual decimal number that they represent. So we can see here that a kilobyte is 1,000 bytes. We have 1,000 here, 1,000 here. It's 1,000 bytes, and represented by the symbol little k, big B, like over here. A million bytes, here's a million. Okay, we represent that by saying MB, symbol MB. Okay, a trillion bytes is a gigabyte, and so on. You'll also notice these go up in values of 1,000. So if I've got 1,000 kilobytes, I have 1 megabyte. If I have 1,000 megabytes, I have 1 gigabyte. If I have 1,000 gigabytes, I have a terabyte, and so on through petabytes, exabytes, zettabytes, and yottabytes. You also need to know about a variety of file types. So you've already dealt with a whole stack of them. We know that when we work with any form of computer file, we are generally looking at different types of files. They can be used across a number of programs, such as JPEGs or text files, or be proprietary, used just for one program or company. And often a proprietary program can be a market leader, and then this file type is accepted as a standard for that type of file, such as docs from Microsoft Word. Okay, all you need to know about file types is they're a whole stack of different things, and all it is, it's a variety of different ways to encode data into a file.